Afforestation is the establishment of a forest or stand of trees in an area where there was no recent tree cover. There are three types of afforestation: natural regeneration, agroforestry, and tree plantations. Afforestation has many benefits. In the context of climate change, afforestation can be helpful for climate change mitigation through the route of carbon sequestration. Afforestation can also improve the local climate through increased rainfall and by being a barrier against high winds. The additional trees can also prevent or reduce topsoil erosion, from water and wind, floods and landslides. Finally, additional trees can be a habitat for wildlife, and provide employment and wood products. In comparison, reforestation means re-establishing forests that have either been cut down or lost due to natural causes, such as fire, storm, etc. Nowadays, the boundaries between afforestation and reforestation projects can be blurred, as it may not be so clear what was there before, at what point in time. An essential aspect of successful afforestation efforts lies in the careful selection of tree species that are well suited to the local climate and soil conditions. By choosing appropriate species, afforest areas can better withstand the impacts of climate change. Earth offers enough room to plant an additional 0.9 billion ha of tree canopy cover. Planting and protecting them would sequester 205 billion tons of carbon, which is about 20 years of current global carbon emissions. This level of sequestration would represent about 25% of the atmosphere's current carbon pool. Australia, Canada, China, India, Israel, United States, and Europe have afforestation programs to increase carbon dioxide removal in forests and in some cases to reduce desertification. However, afforestation of grasslands and savanna areas can create problems of their own. Carbon sequestration estimates in those areas often do not include the full amount of carbon reductions in soils and slowing tree growth over time. Also, afforestation can negatively affect biodiversity through increasing fragmentation and edge effects for the habitat remaining outside the planted area. The term afforestation means establishing new forest on lands that were not forest before, e.g. abandoned agriculture. The same definition in other words states that afforestation is conversion to forest of land that historically has not contained forests. In comparison, reforestation means the conversion to forest of land that has previously contained forests but that has been converted to some other use. There are three types of afforestation. 1. Natural regeneration, where native trees are planted as seeds. This creates new ecosystems and increases carbon sequestration. 2. Agroforestry, this is essentially an agricultural activity carried out in order to grow harvestable crops such as fruits and nuts. 3. Tree plantations, carried out in order to produce wood and wood pulp products. This can be seen as an alternative to cutting down naturally occurring forests. However, the term afforestation can also imply the intentional conversion of native non-forest ecosystems to exotic tree cover and violate biodiversity safeguards. The process of afforestation begins with site selection. Several environmental factors of the site must be analyzed, including climate, soil, vegetation, and human activity. These factors will determine the quality of the site, what species of trees should be planted, and what planting method should be used. After the forest site has been assessed, the area must be prepared for planting. Preparation can involve a variety of mechanical or chemical methods, such as chopping, mounding, bedding, herbicides, and prescribed burning. Once the site is prepared, planting can take place. One method for planting is direct seeding, which involves sowing seeds directly into the forest floor. Another is seedling planting, which is similar to direct seeding except that seedlings already have an established root system. Afforestation by cutting is an option for tree species that can reproduce asexually, where a piece of a tree stem, branch, root, or leaves can be planted onto the forest floor and sprout successfully. Sometimes special tools, such as a tree planting bar, are used to make planting of trees easier and faster. An essential aspect of successful afforestation efforts lies in the careful selection of tree species that are well suited to the local climate and soil conditions. By choosing appropriate species, afforest areas can better withstand the impacts of climate change. Benefits. There are several benefits from afforestation, such as carbon sequestration, increasing rainfall, prevention of topsoil erosion, from water and wind, flood and landslide mitigation, barriers against high winds, shelter for wildlife, employment and alternative sources of wood products. Afforestation projects create employment opportunities, particularly in rural areas, thus promoting sustainable livelihoods. They can create many jobs in various forest-related activities. Forests are an important part of the global carbon cycle because trees and plants absorb carbon dioxide through photosynthesis. Therefore, they play an important role in climate change mitigation. By removing the greenhouse gas carbon dioxide from the air, forests function as terrestrial carbon sinks, meaning they store large amounts of carbon in the form of biomass, encompassing roots, stems, branches, and leaves. Throughout their lifespan, trees continue to sequester carbon, storing atmospheric CO2 long-term. Sustainable forest management, afforestation, reforestation are therefore important contributions to climate change mitigation. An important consideration in such efforts is that forests can turn from sinks to carbon sources. In 2019, forests took up a third less carbon than they did in the 1990s, due to higher temperatures, droughts, and deforestation. The typical tropical forest may become a carbon source by the 2060s. Researchers have found that, in terms of environmental services, it is better to avoid deforestation than to allow for deforestation to subsequently reforest, as the former leads to irreversible effects in terms of biodiversity loss and soil degradation. Furthermore, the probability that legacy carbon will be released from soil is higher in younger boreal forest. Global greenhouse gas emissions caused by damage to tropical rainforests may have been substantially underestimated until around 2019. Additionally, the effects of afforestation and reforestation will be farther in the future than keeping existing forests intact. It takes much longer, several decades, for the benefits for global warming to manifest to the same carbon sequestration benefits from mature trees in tropical forests, and hence from limiting deforestation. Therefore, scientists consider the protection and recovery of carbon-rich and long-lived ecosystems, especially natural forests, to be the major climate solution. The planting of trees on marginal crop and pasture lands helps to incorporate carbon from atmospheric CO2 into biomass. For this carbon sequestration process to succeed, the carbon must not return to the atmosphere from biomass burning or rotting when the trees die. To this end, land allotted to the trees must not be converted to other uses. Alternatively, the wood from them must itself be sequestered, example via biochar, bioenergy with carbon capture and storage, landfill, or stored by use in construction. Earth offers enough room to plant an additional 0.9 billion ha of tree canopy cover. Planting and protecting these trees would sequester 205 billion tons of carbon. To put this number into perspective, this is about 20 years of current global carbon emissions, as of 2019. This level of sequestration would represent about 25% of the atmosphere's carbon pool in 2019. Life expectancy of forests varies throughout the world, influenced by tree species, site conditions, and natural disturbance patterns. In some forests, carbon may be stored for centuries, while in other forests, carbon is released with frequent stand-replacing fires. Forests that are harvested prior to stand-replacing events allow for the retention of carbon in manufactured forest products such as lumber. However, only a portion of the carbon removed from logged forests ends up as durable goods and buildings. The remainder ends up as sawmill byproducts such as pulp, paper, and pallets. If all new construction globally utilized 90% wood products, largely via adoption of mass timber in low-rise construction, this could sequester 700 million net tons of carbon per year. This is in addition to the elimination of carbon emissions from the displaced construction materials such as steel or concrete, which are carbon intense to produce. A meta-analysis found that mixed species plantations would increase carbon storage alongside other benefits of diversifying planted forests. Although a bamboo forest stores less total carbon than a mature forest of trees, a bamboo plantation sequesters carbon at a much faster rate than a mature forest or a tree plantation. Therefore, the farming of bamboo timber may have significant carbon sequestration potential. The Food and Agriculture Organization, FAO, reported that the total carbon stock in forests decreased from 668 gigatons in 1990 to 662 gigatons in 2020. In Canada's boreal forests, as much as 80% of the total carbon is stored in the soils as dead organic matter. The IPCC 6th Assessment Report says, secondary forest regrowth and restoration of degraded forests and non-forest ecosystems can play a large role in carbon sequestration, high confidence, with high resilience to disturbances and additional benefits such as enhanced biodiversity. Impacts on temperature are affected by the location of the forest. For example, reforestation in boreal or subarctic regions has less impact on climate. This is because it substitutes a high albedo, snow-dominated region with a lower albedo forest canopy. By contrast, tropical reforestation projects lead to a positive change such as the formation of clouds. These clouds then reflect the sunlight, lowering temperatures. Planting trees in tropical climates with wet seasons has another advantage. In such a setting, trees grow more quickly, fixing more carbon, because they can grow year-round. Trees in tropical climates have, on average, larger, brighter, and more abundant leaves than non-tropical climates. A study of the girth of 70,000 trees across Africa has shown that tropical forests fix more carbon dioxide pollution than previously realized. The research suggested almost one-fifth of fossil fuel emissions are absorbed by forests across Africa, Amazonia, and Asia. Simon Lewis stated, tropical forest trees are absorbing about 18% of the carbon dioxide added to the atmosphere each year from burning fossil fuels, substantially buffering the rate of change. Afforestation provides other environmental benefits, including increasing the soil quality and its organic carbon levels, reducing the risk of erosion and desertification. The planting of trees in urban areas is also able to reduce air pollution via the tree's absorption and filtration of pollutants, including carbon monoxide, sulfur dioxide, and ozone, in addition to CO2. Afforestation protects the biodiversity of plants and animals, which allows the sustenance of ecosystems that provide clean air, soil fertilization, etc. Forests support biodiversity conservation, providing habitats for about 80% of the world's biodiversity and contributing to ecosystem restoration and resilience. Water management can be improved. Afforestation, as trees regulate hydrological cycles, reduce soil erosion, and prevent water runoff. Their capacity to capture and store water helps in mitigating floods and droughts. Forests act as natural air filters, absorbing pollutants and improving air quality. Urban forestation projects have been successful in reducing respiratory illnesses and enhancing overall air quality in cities. Trees provide shade and cooling effects. By shading and evaporation, forests can lower local temperatures, offering a more comfortable environment in urban areas and reducing the impact of extreme heat. Afforestation in grasslands and savanna. Tree planting campaigns are criticized for sometimes targeting areas where forests would not naturally occur, such as grassland and savanna biomes. Carbon sequestration forecasts of afforestation programs often insufficiently consider possible carbon reductions in soils as well as slowing tree growth over time. Afforestation can negatively affect biodiversity through increasing fragmentation and edge effects for the habitat remaining outside the planted area. New forest plantations can introduce generalist predators that would otherwise not be found in open habitat into the covered area, which could detrimentally increase predation rates on the native species of the area. A study by scientists at the British Trust for Ornithology into the decline of British populations of Eurasian curlew found that afforestation had impacted curlew populations through fragmentation of their naturally open grassland habitats and increases in generalist predators. Questions have also been raised in the scientific community regarding how global afforestation could affect the surface albedo of Earth. The canopy cover of mature trees could make the surface albedo darker, which causes more heat to be absorbed, potentially raising the temperature of the planet. This is particularly relevant in parts of the world with high levels of snow cover, due to the more significant difference in albedo between highly reflective white snow and more darker forest cover which absorbs more solar radiation. Thank you for watching this video.